So this video will be a review for the final exam. There will be one question from each assignment that you've had throughout the course, so the exam won't be too long. You had 11 assignments, and the exam will be April 22nd from 8:30 to about 10:15, because I've got a vaccine appointment at 10:40, so I'll have to dash off at about 10:15, but I'll just make it short enough that you can fit it in that time. Okay, so I'll just briefly go through each of the assignments and the important things you should focus on, but I would strongly recommend that you simply rewrite all of the solutions to all of the assignments and just, if you're going to spend so many days studying, just pick a couple of assignments each day and rewrite them. All the solutions are posted on D2L. Okay, so the week one, the main thing I want you to know about that is how to convert units. And now that we've been through the whole course, you'll notice that the prefixes that we used most often were milli, which is 10 to the minus 3, centi, which is 10 to the minus 2, mega, we did like megapascals, that's a million, and that's 10 to the 6, and then kila for like kilometer or kilogram, and that's 10 to the 3. So we should know how to convert length and distances, times, pressures using those prefixes. So you probably want to do a little summary sheet of how to convert in and out of those prefixes. And then don't forget, you weren't very good at doing area conversions. So you need to know about, for example, millimeters squared to meters squared, and centimeters squared to meters squared, and back and forth. And I made up an extra assignment for those of you who didn't do so great on the pressure assignment, practicing converting those areas. So make sure you go through that worksheet and you know how to do those. Week two was, the most important thing was the trigonometry. And I think you got pretty good at that. I will give you a formula sheet with all the important formulae on it, and I'll do a little video later of that. But for the trigonometry, remember, it's the right angled triangles. And so you need to know SOHCAHTOA, Pythagorean theorem, and which are adjacent and opposite sides to get, mainly to get components of vectors. So we did quite a bit of that trigonometry. So I'll probably just give you a question where you need to get the components of vectors using that triangle. So that was preliminary stuff. Week three, this was adding forces using components. And so this was a direct application of those triangles from the previous week. And this was when you had to make that table, remember? You had the X, the Y, and then you listed your forces, and you had da-da-da-da-da, whatever the components were. And then in the end, so these were the forces, and then you had the net force. You added up all the X's to get F net X, added up the Y's to get F net Y. And so if you want the F net X would be forces to the right minus forces to the left. And F net Y would be forces that point up minus forces that point down. But you can't do that unless you get everything into components. So forces that are at an angle, those aren't any use to you at all until you get them into components. This was also the week where you did some free body diagrams. And in general, you're pretty good at that. Make sure you know how to do it for the inclined plane. So if you have an object on an inclined plane, remember gravity has two components. It has the downslope component, which is the slippery, slidey one, Fg sine theta. And then it has the inslope component, keeping it close. So it's Fg cos theta. The normal is perpendicular to the surface. And if there were friction, if it was sliding down, for example, friction would be parallel to the surface and impeding the motion. So that was free body diagrams. Definitely go over that assignment. Next week was week 4. Oops, week 4, where you were calculating the net force. So this is basically a continuation of the previous week, but now you're actually calculating net force. This was just more applications to bodies and different positions that we were then going to analyze later for torques. Okay, so that's the table, and that's getting the X and Y components. And so that's the same thing as the previous week. Week 5 was when things were in equilibrium. And that's just a special case when the net force is 0, which is what the situation was when we did torques. So this is when net force equals 0. So we did the same thing with this table, except for this time we know that the sum had to be 0 in both the X and Y direction. So you add it up. So these were the forces. You've got the components of the forces. And then if any were missing in the column, you knew how to get them because you know the sum of all the x's equals 0, sum of all the y's equals 0. So basically, right equals left and up equals down for the forces when something is in equilibrium. Okay, then we had a couple weeks break for your exams and reading break. And so then it was week 8. We picked up again, and this is when we did pressure and center of gravity. You're pretty good at the center of gravity. That was a pretty straightforward assignment. It's simply using the formulae, which I'll give you on the formula sheet for the center of gravity in the X and Y directions separately. Pressure, you didn't do so great on pressure. It's force divided by area. It's the concentration of force. It's how it's distributed over an area. And it was the units that were killing you here. The units for pressure are pascals. And the pascal is a Newton per meter squared. So that's 1 unit. And then we had megapascals, which are millions of pascals. But we also had atmospheres. That is also a pressure unit. So I'm not quite sure why things didn't go so well on this assignment. A lot of it was converting area. So once again, back to the very first week, how to convert square millimeters to square centimeters and so on. Okay, so you should definitely review that assignment and review the worksheet if you didn't do so hot on that assignment. Okay, and then really the most important thing I think that you should take away from this course is all about torque. And we simply cannot move our body unless the muscle and tendon and ligament forces create torque about a joint. So those were huge assignments. You did fairly well on them. You need to go over them again. I will definitely put probably 2 nice big torque questions on the final exam. The equation for torque is simple. Torque is just force times lever arm. And getting the force wasn't so bad. It was the lever arm that was tricky. And the lever arm, remember, is the perpendicular distance from the axis of rotation to the line of action. And the axis of rotation is always the joint. And then the line of action is just the line that goes through the force. You could extend it as long as you need to so that you can go from the joint the shortest possible distance to that line. And you've got lots of examples, lots of hints, lots of good diagrams for those torque questions. And it'll be very similar. Probably I'll just pull one of those diagrams right off those assignments and put it on the final exam. So that was definitely I would hope that you have a little bit of understanding about that, and that's super important for your body. Okay, and then I think it got a little easier. Week 11 was the kinematics. the equations of kinematics, with velocity, acceleration. Kinematics is just the description of motion. It's not why things move. It's simply how they move. The relationship between velocity, acceleration, displacement, and time. And then free fall. Remember with free fall, acceleration is always, always, always negative 9.8. Okay, if you are in the air and you do not have a jet pack on your back or wings or, I don't know, or neglecting air resistance, you always have the same acceleration. You are always accelerating down toward the center of the earth, whether you're moving up or not, it doesn't matter. Gravity is pulling you down, your acceleration is down. Okay, so that was, you did a pretty good job with that one. And then this past week was week 13, Newton's laws, where you did a pretty good job of that as well. On that Newton laws assignment, make sure you go over that question about the girl jumping. Some people just left it out. I did a video about it. You should know how to do that kind of question. It's an important question. Some biomechanics courses, they spend like 2 weeks analyzing that one situation alone, jumping up and landing. And they do labs on it, and they do assignments on it, and they go on and on and on and on. So it is an important thing to analyze, to understand for a biomechanics course. So go over that solution again. So Newton's laws, finally, now we're going to use the F net. It's not zero, it's m times a, causes an acceleration. Okay, and those accelerations can be huge if you're, landing with a straight leg and not having any kind of cushioning, or if you're in a collision or someone punches you, you can have big, big accelerations. And then the final week, which is this week, you'll do bones and stress and strain. And I've done a whole bunch of videos on that, so you'll be watching those this week. And I'll just pull one of the questions from that assignment for the final exam. Okay, so that'll do for now. I'll go over the formula sheet in the next video.